Yeah, welcome back. This is Elsam. Today we are going to be looking at number bases. Now we broke number bases into two because we want to keep the lecture simple and interesting. So for this first part, we'll focus on the conversions. Then in the next lecture, we'll look at number bases again, where we'll look at multiplication, addition, division, and all of that. So if you're excited to solve with me, let's go. Now, when you look at number bases, for example, if you are given 24 plus 38, or you are given 55 minus 39. Let's start from this. Now, 5 minus 9 cannot go through, right? You take 1 from 5, remaining 4, put it here, making 15. Now, watch the first thing. You took 1 from 5, and the 1 makes 15. 1 plus 5 is not 15, so bear that in mind. Now, what you have not just been told is that you have been working in base 10, and in base 10, your numbers have a value of 10. So the one you took from this 5 has a value of 10. So it is that 10 plus this 5 that makes 15, and then you subtract. So let's bear that in mind. Now we want to see the number bases for what they are. So we'll look at how to, the number bases and then how to convert. First, in base 10, we have numbers from 0, 1, 2, up to 9. In base 5, we have numbers 0, 1, 2, 3, up to 4. Now, so for base 10, we have 0 to 9. For base 5, we have 0 to 4. And for base 2, we have 0 and 1. So I believe you can see the pattern. So 5 ends at 4, 10 ends at 9, 2 ends at 1. So bear in mind that these are the numbers possible. So if you're asked to look for, let's say you have 102 base 2, this is wrong because you cannot have 2 in base 2. The only numbers allowed in base 2 are 0 and 1. So that's the first thing to bear in mind. And now let's see how to convert from one base to another quickly, and then we'll start solving our problems. Okay, so let's say we have a number 101 base 2, and I want to convert it to base 10. What we do, we give powers from the right hand side from 0, 1, 2, and so on. So the more digits you have, you just keep going down. And then what we do, now remember we're converting from any base. This is base 2 now. It could be 3, it could be 4. So whatever base you are given, we want to see how to convert to base 10. So the major conversions are from base 10, from other bases to base 10, and 10 to other bases at this level. So what we'll do is we'll take the first one. We'll have 1 multiplied by this base, which is 2, raised to the power, which is 2. Plus the second case, we'll have 0 multiplied by the base. In this case, it is 2, raised to power 1. Plus the third one, we have 1 again, multiplied by the base, which is 2, raised to power 0. So, and that's how we do it. So we'll have 1 multiplied by 4, that's 2 squared is 4, plus 0 multiplied by 2, 2 raised to power 1 is 2, plus 1 multiplied by 2 raised to power 0 is 1. Remember, any number raised to power 0, the value is 1. So that's how we do it. And then we'll have 4 plus 0 plus 1, and we have 5. So the implication is that 101 base 2 is equal to 5 in base 10. Now, in most times, the 10 will not be written because that's the standard number system. So this is how to convert from other bases to base 10. So if this was 3, you work with 3. If it was 4, you work with 4, and so on. Now, when you're converting from base 10 now to other bases, so let's just go back. Let's pick this 5 and convert it to base 2. So what you do, you just pick your 5, and then you are dividing it by 2 because we want to convert from base 10 to base 2. So we're dividing by 2. If you are converting to base 3, you divide by 3. So we divide this 5 by 2. So how many 2's do we have in 5? We have 2 remainder 1. You divide by 2 again. How many 2's do we have in 2? 1, remainder nothing. So we put 0. Now, how many 2's do we have in 1? Cannot go, remainder 1. And at the values, we take them up, from down, up. So our answer will be, from down we have 1, followed by 0, followed by 1 in base 2. So, as you can see, 1, 0, 1, base 2, we converted it to base 10, we had 5. Now 5, we converted it back to base 2, we had our 1, 0, 1. So that's the basic thing we need to understand for this lecture. Now let's apply that to solve the problems we have. Let's go. So the first question here says, write the decimal number 39 to a number in base 2. So 39, decimal number, that means it is in base 10. We want to convert it to base 2. So number 1, we have 39 in base 10. We want to make it to base 2. So what do? Exactly what we've just learned. We divide. So we'll keep dividing the 39 by 2 because we are going to base 2. So 2 in 39. So that's 19. Remainder 1. 2 in 19 again. We have 9. 2 multiplied by 9 is 18. Remainder 1. 2 in 9, we have 4, right? Remainder 1. 2 in 4, we have 2. Remainder 0, because 2 divided by 4 is 4 divided by 2 is 2. Now 2 in 2, we have 1, remainder 0. And then 2 in 1, we have 0, remainder 1. So remember, we count upwards, right? We count this way, or we'll get our values upwards. So what we'll have is 1, 0, 0, then 1, 1, 1, 1, 1, 1 in base 2. So do we have an answer that looks like that? So 1, 0, 0, 1, 1, 1. That will be option A. So our answer is option A. Okay. So number 2 now says convert 1, 1, 1, 0, 0, 0, 1, 1 in base 2 to a number in octal scale. Octal scale. Now what does that tell you? So we're to convert from base 2 now to base 8. So the octal number is a number in base 8. So we're to convert from base 2 to base 8. Now we've only learned to convert from base 2 or other bases to base 10 and from base 10 to other bases. So what we do in this case, we'll first of all convert the number to base 10. And now once it's in base 10, we use this method to convert it to base 8. So let's go. So what we have is, we're solving number 2 now. What we have is 1, 1, 1, 0, 0, 0, 1, 1, base 2. We're converting to base 10. Remember, we are going this way. So we have 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so the first will be 1 multiplied by 2 raised to the power 7 plus the second one, 1 multiplied by 2 again. These two, the base, raised to the power 6 plus 1 multiplied by 2 raised to the power 5 plus 0. All of this 0 will give us 0 plus, let's just skip them for the sake of exam. All of these values, 0 multiplied by anything will give us 0. So skipping to this point, we have 1 multiplied by 2 raised to the power 1 plus the last one, 1 multiplied by 2 raised to the power 0. So I believe you understand why I skipped all of these zeros, because all the values will end up being 0. Okay, so let's come from this way. So here we have 1 multiplied by 1. Here will be 1 multiplied by 2 raised to the power 1 is 2. 1 multiplied by 2 raised to the power 5 is 32. 1 multiplied by 2 raised to the power 6 is 64. Then the first one will be 1 multiplied by 2 raised to the power 7 is 128. Okay, so 128 multiplied by 1, so we have 128 plus 64 plus 32 plus 2 plus 1. So let's add 8 plus 4, that's 12, plus 2, that's 14, 16, 17. So I have 7, carry 1. So that 1 plus 3 is 4, plus 6 is 10, 10 plus 2 is 12. I write down 2 and carry 1 again. So I have 2, 2, 7. So 1, 1, 1, 0, 0, 0, 1, 1, base 2 is 227 in base 10. Now that's not what they want, because we're required to convert to base 8 octal number. So how do we do that? So we'll pick our 227 and now we're converting to base 8. So we're dividing by 8. So 8 in 22, that's 2, that's 16. Okay, that's 16 plus 4 is 20, so 6. Now 8 in 68, so that's 8, 64, remainder 3. Now 8 in 28, 8 times 3 is 24, remainder 4. Now 8 in 3 obviously cannot go, that's 0, remainder 3. So remember we count upwards, right? So 343 is our answer, 343 in base 8. Okay? Oh, sorry. We didn't provide options here. So our answer to this is 343 in base 8. Okay, so that was number 2. Yeah, let's continue. For number 3, we have this question that says if 263 plus 441 equals to 714, what number base has been used? Okay, so the base is not given. We are required to look for the base. All right, so let's do it together. So for number 3, we'll have 263 plus 441 equal to 714. So we're looking for the base that was used. So they will all be in the same base. So let's just give it n as our base. Now we can convert to base 10, convert everything to base 10, and then we'll get our n. So let's do that. So this is going to be, remember our 012, 012, 012. So this is going to be 2 multiplied by n, the base, raised to the power 2, plus 6 multiplied by n raised to the power 1, plus 3 multiplied by n raised to the power 0. So this is for this, plus, let me be economical with the bird. So we'll have 4 multiplied by n raised to the power 2, plus 4 again multiplied by n raised to the power 1, plus 1 multiplied by n raised to the power 0. Okay, equal to, let me just bring this one down. We'll have 7 multiplied by n raised to the power 2, plus 1 multiplied by n raised to the power 1, plus 4 multiplied by n raised to the power 0. So this will give us 2n squared plus 6n, yes, plus 3. So I believe you're following. So this is the 2n squared, this is the 6n, This is the 3. N raised to the power 0 is 1. 1 multiplied by 3 is 3. So we've explained that earlier. Plus 4n squared plus 4n plus 1 equal to 7n squared plus n plus 4. So let's do the like terms thing. So 2n squared and 2n squared. Sorry, 2n squared and 4n squared. That will give us 6n squared. Let's just bring this 7n squared inside. So, okay, let's do this side and this side separately. So we'll have 6n squared. So for the n's now we'll have plus 10n plus 3 plus 1, 4. So equal to 7n squared plus n plus 4. So if we rearrange this, it will give us n squared minus 9n equal to 0. Now look at it very well. Look at it very well and picture what I did. So 7n squared, I brought this 6n squared this way. So 7n squared minus 6n squared, that's 1n squared, right? Now we have 1n here. This plus 10, bringing it this way becomes minus 10, right? So 1 minus 10, that's minus 9. So that's our minus 9n. Now we have positive 4. We bring it here, it becomes negative 4. So 4 minus 4 is 0. So that's how we got this. So from here, we can factorize n into n minus 9 equal to 0. So from here, it's either n equals 0. Remember, when you have a product equal to 0, it's either the first n equals 0 or the second n minus 9 equal to 0. And then our n equals 0 or n equal to 9. Yeah, so that's our answer. Okay, so we're taking time to explain, so that's how the video is long. Now, in some other series, we'll get into exam mode where we'll just be fast. 1, 2, 3 steps to get our answer. Now, we're trying to make you understand, so hence we're taking the time. So that's number 3. So for number 4, we have to divide this by this. Remember, the bases are different, and we're leaving our answer in binary. So what we can do is to convert this to base 10, convert this to base 10, divide them in base 10 with your calculator, your normal division, and in the answer, we convert it to binary. So let's go. So for number 4, we first of all have 1, 3, 2, 4 in base 8. Let's convert it to base 10 quickly. So remember our 0, 1, 2, 3. So this gives us 1 multiplied by 8 raised to the power 3 plus 3 multiplied by 8 raised to the power 2 plus 2 multiplied by 8 raised to the power 1 plus 4 multiplied by 8 raised to the power 0. So this is 512 multiplied by 1, 64 multiplied by 3, that's 64 multiplied by 3, that's 192, 8 squared, 8 raised to the power 1 is 8 times 2, 16 plus 4. So 6 plus 4 is 10, plus 2, 12, plus 2, 14. Add on 4, carry 1, plus 1 is 2, 2 plus 9, 11, plus 1, 12. Add on 2, carry 1. So we'll have 5, 6, 7. So we have 724 as the first part. So the second one, we have 20201 base 3. So if we apply the same thing, 0, 1, 2, 3, 4, we'll have 2 multiplied by 3 raised to the power 4 plus the 0. Anyone that has 0, just skip it because the value will end up being 0, plus 2 multiplied by 3 raised to the power 2, plus 1 multiplied by 3 raised to the power 0. So we skipped these 2. So 3 raised to the power 4 is 81. 81 times 2, that's 81 multiplied by 2. You have 2, that's 162, plus 9 times 2, 18, plus 1 times 1 is 1. So 1 plus 8 is 9, 9 plus 2 is 11, 1 carry 1, plus 1 is 2, 2 plus 6 is 8, so 181. So what we'll do next is, since we're supposed to divide, the question says divide this value by this. So now this has given us 724 and this has given us 181. So if we divide both, we're going to have 724 over 181. And that will give us 4. You can press it on your calculator. It will give you 4. Now, this 4 is in base 10. But now the answer is needed in binary base 2. So we'll simply convert this 4 to base 2. So 4, remember to convert, we divide by 2 because we are going to base 2. So 2 in 4 is 2 remainder 0. 2 in 2 is 1 remainder 0. And 2 in 1 is 0 remainder 1. So we have, remember we are counting upward. So our answer will be 100 base 2. And that will be option C. Okay, remember when we solved question 3, our answer was 9 or 0. So 9 is our answer. So option D is the correct answer. So the last one but not the least, we are required to... Okay, this is similar to what we've done earlier. The question says if 124 base n equals to 232 base 5. So this one is even clear. We can just convert both to base 10 and then we'll get our answer easily. So let's do that quickly. I need to rub the board. So let's convert both to base 10 and then we'll get an answer. So we have 124 base n equal to 232 base 5. So if we convert everything to base 10, we'll have what we can work with. So let's do it. So 0, 1, 2, 0, 1, 2. So this will give us 1 multiplied by n raised to the power 2. Yeah, I like putting it in brackets for clarity. Plus 2 multiplied by n raised to the power 1. Plus 4 multiplied by n raised to the power 0. Equal to, here is base 5, so we'll use 5. So we have 2 multiplied by 5 raised to the power 2. Plus 3 multiplied by 5 raised to the power 1. Plus 2 now multiplied by 5 raised to the power 0. So this will give us n squared plus 2n plus 4 equal to 5 squared is 25 times 2. That's 50. 5 raised to the power 1 is 5. 5 times 3, 15. Plus 5 raised to the power 0 is 1. 1 multiplied by 2 is 2. Okay, so what do we do from here? Like terms. So we have n squared plus 2n plus 4 equal to 50 plus 15. That's 65. Make it plus 2, 67.